Alright, ladies and gentlemen, we are today multiplying and dividing rationals, which means we are multiplying and dividing fractions. And hopefully you remember how to multiply fractions. For multiplying fractions, we literally just multiply across. Now, I don't mean cross multiply. It means when you have a fraction and you have A and B and C and D, you multiply directly across. Okay? That's A over C times B over D. We do not cross multiply. That's when they have equal signs between them. For these, you just do that. When you want to divide fractions, maybe my crazy chicken friend, keep it. Change it. Oh wait, sorry. Keep it, change it. Looking at my own notes and confusing myself. Flip it. Okay, when I say change it, I mean change the sign from divide to times, and then flip it means the second term reciprocal. And it is the same thing as dividing, and it's just much easier. Okay? So, and then multiply across. We then do exactly what we did in the previous section, which is just factor and cancel, or eliminate, or simplify. Okay? Because that's what you're going to be asked to do here. Okay? Multiply this expression. We need to always KCF it when we're dividing. Okay? But let's just look at what we can cancel. Can I cancel anything out of these? Can I cancel anything out of these? Nope. Well, I could actually cancel a 6 out of these. So I get a 4 there and a 5 there. Well, I got a 5 here that I can cancel with that. Does 4 go into both of those? It does. I suppose you can use a calculator for this. 4 goes into there 1 time. 4 goes into there 14 times. All I got on top left is 1. My x is here. Oh, let's see. I can take 2 out of there and 2 out of there to get x squared. I can take 3 out of there and 3 out of there to give me x cubed. Or excuse me, x squared. And I got an x squared here and an x squared here. All I'm left with is 14. 1 over 14 is my answer. Again, we set the denominators equal to 0, but anytime it's a monomial, it's always just x cannot equal 0. And that's it. All right. For number 2, factor and cancel. Factor the tops. 2x and x. I'm going to keep factoring these tops because if it's multiply, it's really just this times this all the way across. And that's difference of squares. I'm going to go there right away. This is just x minus 4. This is x and x. Well, this one's pretty easy. The factors of 15 are 3 and 5. 15 and 1. Okay, so let's factor this one out. Factors of 3 are just 1 and 3 because it's plus plus. I got 1 and 6 to give me 7. Now let's start canceling. I see an x minus 4 that'll cancel. I'll see an x plus 3 that'll cancel. And I got an x plus 5 that won't cancel with anything else out. So what's left is my answer. I'm not asking you to even multiply back out or to distribute things or to FOIL. You can leave it just like this. And what can x not equal? Same as yesterday. Look at your denominators and set them equal to 0. Right there, plus it to get 4. Right there, set it equal to 0. Subtract it to get negative 5. And same thing with that to get negative 3. So there's, again, 2 answers to these just like there was yesterday. The simplified version and the restrictions. For divide, though, divide, again, keep it, change it, flip it. Right? So we keep the first term. I'm going to factor it out at the same time. X minus 4 over 3x and x. Factors of 4 are 4 and 1, 2 and 2. I'm here to tell you that's how it worked out. Plus, minus, change it to a divide sign, flip this fraction. So, what's on top is the 7x term, and 7 is prime, so I can go right to 7x and x. On bottom, I'm going to factor this out. A 5 goes into both of those, x and 4 times, and I just divided 5 out to get that. Now, I don't get rid of that 5, it stays in the factor. On top, I get 7x, let's see, 14, yep, that's it, 5, 2, minus, minus. Negative 14 and negative 5 gives me the negative 19 I got. Okay, I can cancel the x minus 2's. I can cancel those x minus 4's. What's left is 7x minus 5 on top, and 5 times this on bottom. I don't care if you write 3x plus 2 parentheses times 5. I think it's more proper to write it like this. That's it for the solution. What can x not equal? If I set this equal to 0, I would minus 2, divide by 3 to get negative 2/3. Set this equal to 0, I would add 2. I set this equal to 0, I would add 4. And there's my answer. If you distribute this 5 to write 15x plus 10, there's nothing wrong with that either. And that's all I would do in class. Then I would get you going on it. Okay, so I want you to do 4 through 9, press pause, work 4 through 9, come back and check your answers. I'm going to go through them currently. I can't cancel anything here. I can't cancel anything here, so I'm going to go across. I could take a 9 out of there once and a 9 out of there 5 times. I could take a 7 out of there twice. I can take a 7 out of there 5 times. X 6 over x third, I'm going to cancel those to give me x third on top. X second, x third, I'm going to cancel those to give me an x on bottom. Then I'm going to rewrite everything here. I got 2x cubed over 25x. And I'm not done yet. I still got x's on top and bottom. I could take an x out of there and an x out of there, and I'm left with 2x squared over 25. Again, this is a monomial. There's one term, so x cannot equal 0 is my only restriction. Still multiplying here. Factor the top. I've got x plus 2, x minus 2, x plus 1. Factor the bottom, x plus 1, x minus 1. The GCF here is x times x plus 2. What am I doing here? I got these to cancel. I got these to cancel. I can see what's left. X minus 2 on top. X times x minus 1 on bottom. Again, if you flip those around, that's okay. X cannot equal. That 0 is negative 1. That 0 is 1. That is a monomial, so it's 0. That 0 is negative 2. We got a lot of restrictions on that one. That's going to happen sometimes. If you write this as plus or minus 1, that's cool. X minus 1's cancel. And that's it. No, x minus 5's cancel. And look what I'm left with. I can't cancel these two out. I can't even take a negative out because I get a negative x. So there I'm left with. And my restrictions. 5, 1/3, and 2. Now all of these down here are divide for the next two. This one's the times. We're going to get to that. So I'm going to keep it, change it, flip it here. So I've got x change it, flip it. This is 3 times x minus 4. That becomes on top because I'm flipping these. And x plus 5 just goes on bottom. Factors of that are 5 and 3. Yep, it's going to be a plus 5 and a minus 3 to get my 2 in the middle. The x plus 5's cancel, the x minus 4's cancel. There's my answer with my restrictions, negative 4, 4, and negative 5. Keep it, change it, flip it. That changes to a times. Here I've got 6 times x minus 3. That is 2x and x. If you're not seeing what I'm doing on these, again, I'm flipping the second term and then rewriting it as factors. 7 and 1, so 7, 1, minus, minus. What cancels? We got an x minus 3 that cancels. We got a 2x minus 1 that cancels. And that's it. And then the last problem, which there's 3 terms here, but it's still all multiply across, all multiply bottom. So I've got, this is 3 times x minus 3. I can factor out GCF. I can factor out GCF there. I can factor out GCF there. I can factor this to x minus 3, x plus 2, and start canceling. I've got, see, an x minus 2 that cancels with an x minus 2. I've got an x plus 2 and an x plus 2. I got an x minus 3 and an x minus 3. Well, that pretty much does all the top, right? What about the bottom? Well, I still got that 4 there. I also still got that x plus 4 there, okay? But wait a minute, I still got a 2 on top. Let's just rewrite what we got. 3 times 2 is 6 over 4 times x plus 4. Well, you know how to reduce that. You can take a 2 out of each of these and get 3 over 2 times x plus 4. That is a simplified answer. What can x not equal? From here I get 2. From here I get negative 4. From here I get 3. From here I get negative 2. So it's just this. Just this. Okay. All right. That's it. Seems like a lot. It's not. It's not that bad. Okay. 1 through 17 is your homework. Okay. You can do this. You need a lot of examples of it. I think there is a repeating problem somewhere. Now that I think about it, let me check mine here a second. Yeah, you can scratch off number 10. Okay, that's a repeating problem. And I think that actually might be it. Yep, that's it. So really it's 16 problems. Do your homework. Have a good day.